proportion has got a variety of meaning. In mathematics, the word simply means the relationship between one thing with regard to another. There are so many examples in real life situations where the concept of proportions is used. Hello everyone, my name is Ragwani Khari with Junior Certificate Mathematics lesson, and the topic is proportions. Now, before we start or we develop this topic further, let us have a look at what the objective says. That is what is going to guide us in our discussion today. The lesson objective simply says solving problems involving the direct proportion. So this is what we are going to be dealing with. We will be solving problems that involves the direct proportion. But before we can go on, let us have a look at what the direct proportion is all about. The direct proportion says two quantities are said to be in direct proportion if their ratio stays the same as the quantities increase or decrease. That is, when you increase the quantities, the ratio stays the same. When you decrease the quantity, their ratio stays the same. And to also find out that the direct proportion is a common measure of rates. If, say, you are paid according to the number of hours that you work, your payment will be calculated basing on the direct proportion. Now, I have got a student here with me, Thabang. Let me invite him and hear from him what he wants us to cover.
Good day, everyone. Thank you, Mr. Khare. I have understood how to describe direct proportion. But can you give examples to elaborate on what you have explained?
Thank you, Thabang. You are saying I should give an example and elaborate more on the direct proportion. Let us have a look at the example here with me. The example question says, a man working for a factory is paid according to the number of hours worked. This is what determines what is going to be paid. Then it says represent this information in a graph if he is to pay 50 pula per an hour. If he is to be paid 50 pula per an hour. Right. You need a graph sheet. This is what I have here. And then we need to construct a table of values. Here on the other side, this is time, and then the wage. That is what is going to be paid. And let us bear in mind that it says he's paid 50 pula per an hour worked. Now let us take the 1 hour. Say this man works for 1 hour. If he works 1 hour, then it means the wage for this 1 hour will be 1 times 50. This gives us 50 pula. And then what if he works for 2 hours? It will be, this is 1 time is 2 hours, 2 times 50, giving us 100. 100, not 10. And then, what if this man works for, say, 7 hours? That will be 7 times 50. And then 7 times 50, that is the number of hours here, 7. And then the wage, this will be 350. 7 times 50 is 350. This is what we have. We will now represent this information in our graph here. Remember we said the direct proportion, in direct proportion, as one quantity increases, the other one also increases. So we expect these quantities to be increasing at the same rate. And now let us check, let us graph this and check if at all there's an increase on the two parameters that we are having. The first point is 150. So let us plot the point 150. Let us plot the point 150. 150. It's here. This is the point 150. If this man works for 1 hour, 50 pula paid. And then the second point, if he works for 2 hours, it's 200. It's here. It's 2 hours, then will be paid 100 pula. Then what if this man works for 7 hours? If he works for 7 hours, it will be 7 hours, and then will be paid 350. So 7 hours is here, and then we are saying he'll be paid 350. This is the 350. 350, it's here. Right. Now these are our points. After getting these points now, it says we are to represent this information in a graph. What you have done is simply to plot the points. Now we have to go on and draw the graph for these. Take a ruler and then draw a straight line passing through the plotted points. And this is where our line is going to pass. Right. So we can see that this is the line passing through all the 3 plotted points. We can see that now when you increase the number of hours, the wage also increases. You can see that when the hours is 2, then he will be paid 200 pula. But when you reduce the hours to say 1, the wage will be 50 pula. And when he didn't work any hours, he won't be paid. So we can see that the wage and the time are directly proportional to each other. They are increasing at the same rate. Right. Now, what if this man works for, say, 6 hours? 6 hours will be here. This is the 6 hours, and then to be 6 hours, the man, what if the man works for 6 hours is from here, the 6 hours is from here up to here, then if he works for 6 hours, it will be 300 pula. You can always actually check along this line the amount of money that will be paid as he works, say, a certain number of hours. This is the direct proportion, and I want to believe with this, it has explained it even further. You should just remember that when we deal with the direct proportion, we expect the quantities to be increasing at the same rate. I think you still have another question that you want to ask, and I'll give you time to ask that question.
Thank you, sir, for the examples you have discussed. But what about situations where you are not to draw a graph? Can you discuss such examples?
Thank you. Your question is, what if you are to calculate the simple interest without using a graph? That is when the question is given and then you have to represent it not using a graph. Yes, we can do that. Let us have a look at the example here with me and then see what you can do. This is the example. The example says Amandla paid 1 pula for 4 sweets. If she wanted to buy 11 sweets, how much was she going to pay? Let us remember that Amandla paid 1 pula for 4 sweets. Then it says, if she wants to buy 11 sweets, how much will she pay for 11 sweets? This is how we'll work this out. 1 is to 4. Remember, this can be in the form of ratio. So 1 is to 4. That is one pula for 4 sweets. And then it says, how much will he pay if she is to buy 11 sweets? Now, 11 here will be to the say a variable. Can call it x. Call it x or y. Let us call it x. So this is the ratio of money to sweets. 1 pula, 4 sweets. X pula to 11 sweets. And then let us find out how much will this person pay, rather how much Amanda will pay for the 11 sweets. This is how we'll do it. 1 times 11, it's 1 times 11 will be equals to the 4 times x. So it's equals to 4 times x. 4 multiplied by x. So this is what we have. Meaning our 4x is equals to 11. So 4x is equals to 11. Remember, we are to solve for the variable x. Now, to find the value of x, we'll have to divide both sides by 4. Divide here by 4. And then your x will be 4 into 11. This will be equals to 4 into 11 is 2. That is 2 times 4, it's 8. Remainder 3. Remainder 3, and then 4 into, let me write this as x equals to 2 and 2/3. This simply gives us 2.75. Let us go for a short break. When we come, I'll explain further on this. Welcome back from the short break. Remember, Thabang, we are still working out the situation where we were to find the cost of 11 sweets when 4 sweets cost 4 sweets cost 1 pula. And then we found out that the 11 sweets will cost 2.75. This 2.75 means the value of your x here is 2 pula 75 tebe. Remember, money is always written correct to 2 decimal places. So this is how we write it. It's 2.75. So it's 2 pula 75 tebe. This is how we do it. I believe you still have another question that we want to ask to benefit you and of course other learners.
But can you give examples to elaborate on what you explained?
You are saying I should give another example. Let us have a look at another example to try and elaborate more on the direct proportion. The next example says a car uses 10 liters of petrol in 75 kilometers. How far will it go on 8 liters? So what we know is for 10 liters, this will go for 75 kilometers. And then the question says how far will it go on 8 liters? Now our ratio will be liters for L. Let me use L for liters, and then the distance for kilometers. What we have for is 10 liters to 75 kilometers. Then from here, it says how far will this go for 8 liters. Remember, the parameter for liters should be under the liters, and then those for the distance should be under distance. So we will have the 8 under the 10 here, because the 10 here is for the 10 liters, and then this side under 75. Just use another variable, y. Doesn't mean that always have to be x. So let us use the variable y, and then find out what our y will be. So 10 is to 75, and then 8 is to y. We want to find the distance that the car will travel on 8 liters. Now, multiply, to find the value of y, you will multiply 10 times y, which will give you 10y to be equals to 8 multiply 75. This is what we have. 10y equals to 8 times 75. You can get your calculator. If you cannot multiply this, then punch in these numbers. Then after all, get the answer, divide by 10. This will be 600. Meaning our 10y is equals to 600. Now remember, we are solving for the value of y. You will now divide both sides by 10. Divide here by 10 as well. And then what will we get on divide by 10? 10 here once, 10 here once. This simply means on this side you got a y, it's equals to, and then 10 here once, 10 here, this 0 cancels this. Then we've got 60. So our y is 60. Now let us go back to the question and find out what the question wanted us to find. It says a car uses 10 liters of petrol in 75 kilometers. How far will it go on 8 liters? And we are saying on 8 liters it will go 60 kilometers. So this will be the 60 kilometers. This is the distance the car will cover using 8 liters of petrol. As you can see, we said this is the direct proportion. When one side increases, the other one decreases. So we are saying for 8 liters, it will go for 60 kilometers. We expect that to be less than 75. This was 10 liters. And then at 10 liters, we can see that it traveled for 75. Now, when you reduce the number of liters, we expect the distance also to reduce. And this is what had happened. We managed to get 60. And that's very correct. I think you have understood that, Tabang. Let me give you another example to try and elaborate this more. This is the example that I'm having here with me. 9 milk bottles contain 4.5 liters of milk between them. Find out how much do 5 bottles contain. So here we are told that the 9 milk bottles contains 4.5 liters. And then it says find out how much 5 bottles will contain. 5 bottles will contain. 9 milk bottles contains 4.5. It's 9 and then 4.5. But then when you reduce the number to 5, what should happen to the liters? We expect these liters also to decrease, because here this was 9 liters and then here it's 5. So we expect the liters for 5 bottles to decrease. That is, should be less than 4.5. Let's check if at all that's going to decrease. 9 is to 4.5. 9 is to 4.5. And then what about the 5 bottles? 5 will be to x. So this is what we are having. The 9 bottles contains 4.5, and then what about 5 contains x? So we have to find the value of x. How do we find the value of x? we will multiply 9 times x. 9 times x gives us 9x. Then this will be equals to 4.5 times 5. 4.5 times 5. And then to find the value of x, you will divide both sides by 9. Divide here by 9. Your x now will be 4.5 times 5 divided by 9. 4.5 times 5 divided by 9. We can always get our calculator and then divide. It's 2.5. This is what we get. Now, let us check what the question said. The question says we are to find out how much 5 bottles will contain. Now we can see that we reduce the number of bottles, and because we reduce the number of bottles, we expected the number of liters also to reduce, which is 2.5 in this case, and it's very correct. Let us go for a short break. When we come, we'll continue with our lesson.
Thank you for this opportunity once more. I'm thinking of foreign exchange. What do you use to change from currency of one country to another? Don't you use direct proportion? If so, elaborate by means of examples.
You are doing very well, Taban, to ask those questions because they don't only benefit you, they also benefit other learners home. You are not saying you are thinking about foreign exchange, that is currencies of different countries. The question here with me will help you understand how foreign exchange works. The question says, the conversion rate of the Botswana pula to South African rand is given as 1 pula is equals to 1.20 South African rands. Then it says a South African gentleman on holiday at Kasane in Botswana finds that his wallet contains 1,200 pula, rather 1,200 South African rands, not pula. If he changes the money at a bank, how much Botswana pula will he receive? Now, we are saying we are converting from the South African rands to Botswana pula. So this is just a straightforward conversion. It uses the concept of proportions, and we are going to work it out to find out how you can deal with this. Let us see what we can do. 1 is to 1.20. That is for every 1 pula, then 1 plus equivalent to 1.20 South African rands. Then it says 1,000 South African rands is equals to how many Botswana pula? Now, the South African rands should be under the South African rands, so this will be 1,200 is to the variable. Let us use variable y. It doesn't matter, variable y. Right. Now, we need to find out what this y is. Remember, we just need to know how much 1,200 South African rands, the equivalence of 1,200 South African rands to the Botswana pula. And then this is how we do it. Multiply y times 1.20. 1 times 1.20 times y is just 1.20 y. It's equals to 1,200. Then divide both sides by 1.20. 1.20. We are to divide by 1.20. Divide by 1.20. Remember to divide both sides by 1.20. 1.20 as well this side. 1.20 cancels the 1.20. So on this side, you are remaining with y. So y will be equals to, your y will be equals to, what about 1,200 divided by 1.20? This is 1,200 divided by 12. I'm just multiplying the top 10 by the numerator here by 10, and then multiply the denominator by 10 as well. That's how you get the 12. Then this will be 12 here once, 12 here once, into this 0 is 0, into this one is 0, and then the last one will be 0. So our y will be, the value of y will be 1,000. That is the value of y. Our y is equals to 1,000. This is simply saying 1,200 South African rands. It's equivalent to 1,000 pula. That is the exchange rate between the Botswana pula and the South African rands at that time, of course. So we are simply saying Y will be equals to 1,000 pula. So this gentleman will find that at the end of the day, the 1,200 South African rands will equate to 1,000 pula. This is how we do it. Let us look at another example and find out how you can convert between these currencies. Another one says, on a different day, Khotla wanted to go to South Africa. He changed 2,000 pula and was given 2,380 South African rands. What was the conversion rate on that particular day? So this person has got 2,000 pula, but then upon changing to the South African rands, he got 2,380. Then he says, find out what the conversion rate was on that particular day. So we are simply saying 2,000 will give you 2,300. 380 rather. This is what we have. We now want to know how much Botswana pula is when compared to the South African rands. You can divide here by 2,000. By dividing by 2,000, you are saying you need to know what one pula will be equals to when converted to the South African rands. So let us work that out. So 2,000 divided by 2,000 will be equals to 2,380 divided by 2,000. Then the 2,000 cancels this 2,000. So this will be 1. It's equals to, now 2,380 divided by 2,000. This 0 will cancel this. So we got 238 divided by 200. This is what we have. Let us take our calculator and then compute this. 2,380 divided by 2,000. 238 divided by 2,000. 200, not 2,000, but 200. And then what do we get? 1.19. So we are simply saying, on that particular day, 1 pula will be equal to 1.19. This is simply saying 1 pula is to 1.19 South African rands. So this is the conversion rate on that particular day. And we can always write this as 1 pula, P for the pula, will be to 1.19 South African rands. So that's what we are having. This is the conversion rate on that particular day. And let us understand that it does not mean that we can only convert between the South African rands and the Botswana pula. You can always convert between other currencies when given the conversion rate or when you are expected to find the conversion rate. Thabang, I think you have now enjoyed this lesson. We have now discussed everything that we expected to cover under this lesson. Remember, we were dealing with the direct proportion. This is what the objective said. This is what guided our discussions today, the direct proportion. And remember, under the direct proportion, as one quantity increases, the other one increases as well. We also covered currencies, which we said deals with the concept of proportion. And I believe you have gained a lot. Thank you, Thabang and other junior certificate mathematics students. I want to believe you have enjoyed this lesson, and please keep revising proportions. Till we meet again in our next lesson, thank you.